It's recording.
Me too.
Like,
Mike,
wait, I can't even see that.
Nope.
No, we'll just put a thing before.
Oh, and just say it's like slides
Yeah.
5 through 70.
Oh, hey. Can someone Photoshop for that for me?
Oh, yeah. Just like put it in the background.
Yeah. Gravitational I've been working on.
Okay, this is legit all just still centripetal motion stuff. It's just now it's got a bank. So should I say what page this is?
Nope.
No, cool.
That's not a page, that's a slide.
Okay, same thing.
No, I'm saying like we put a picture of the slide before each of the things.
Oh, like slide 15.
Oh, I thought you were just gonna say we use these slides. Go
I
look
mean,
them
if
up.
Danny always wanted them.
Well, we'll see. I might just slap a link in the description at the end.
Link in the description. Okay, anyways.
Cool, Danny.
So what we have here is a cyclist going around a velodrome, as you do. And in this velodrome, we assume that the cyclist is a block mass because we can. So we have XR being the R component, the X component of the reactant force, which is equal to Fc, because of course it is. Centripetal motion is going that way, that's going that way, so they're equal, which is all equal to R sine theta, and Fc is mv squared over R.
Can you guess who did the systems? Because it's slightly online.
Hold up. I can just put my mouse over it.
Oh, nice.
Oh, nice. Big brain.
I know, right? I probably should put in the like the FC and it doesn't matter. Anyway, so that means R sine theta v squared over R. Oh. Find the angle of the slope given V, R, and G. So we just don't actually. Okay. Just rearrange this then. Oh wait. Oh shit, yeah. What am I doing? I've not left enough space. Y R M G F C F C is equal to V squared over R. Okay, sorry. Yeah, that's what we've got. And we've also got the R cos theta. And then we can do some lovely division. X over R, and we get, ta-da, surprise, surprise, R sine. This is equal to tan theta. If people can remember, sine over cos is tan, which I think it tells you. Lovely. And then this will all equal mv squared over R over mg, because you divide xr is equal to fc, fc is this is equal to mg, mg is therefore, you know, if you're dividing r sine by r cos, then you divide fc by mg, so that's all equal to mv squared over r all over mg. Tan theta is equal to v squared over r g, and then you just tan minus 1. Ooh, because we just leave it in terms of v, r, and g, and that is what we get. Love. Oh. Or we can just leave it in the tan theta, because you can. Either or works.
Sorry, my mask is
Yeah.
concealed.
Oh yeah. Probably should note we ignore friction. Even though even though sometimes you don't ignore friction. Oh wait, you guys are.
Well, It's circles, so friction would be a gigantic pain. So we could,
Yeah, that's a good point. Okay, yeah, circular motion. No, no, but we do use friction sometimes.
On a wheel though. Might be a bit
Yeah,
weird.
maybe not bank, but anyways. I guess. So leave that. Actually, you guys can copy it off there. What am I doing? So we have next question. Oh, lovely. I don't have to go through. Okay, if we include friction, we can move faster. Yeah, even though you would assume that you move slow. Just
Why is
because
that?
Because you stick on the wall.
you stick on the wall. Yes.
'Cause
Okay,
there's-
so find the maximum velocity when the bike is about to slide up the slope. Friction is equal to mu because we don't get values for this question.
Oh yeah.
Oh my god. Yeah, go ahead. Okay, so we have. Can't roll. We have all these four. Oh, yes. There we
I
go.
mean, you could put it on the blackboard and draw on top.
Yeah, well, we moved it so it wasn't on the blackboard and then we have to move.
No, but if it's on the blackboard, the text is black.
Yeah, you're not going to be able to see the text.
Swap the colours.
Oh, well, I don't know, maybe.
We can do it later. Okay,
During a free period, maybe.
so again, we have x and y components because we need x and y components. So we will start off with equating the x value of it to the fc. And we all know this one equation. Okay, so we will have x of fr, I guess, is equal to mu r cos theta. Oh, I may need to add them, yeah. Because, as you can, yeah, they're both acting in the same direction. Mu r cos theta. Yeah, cos. Add what we got before, which is r sin theta, which is all equal to fc. Yeah. Again, we know what fc is, and we do the same with y. Y of fr plus y of r is mu r sin theta plus r cos theta, which is all equal to mg. We can do division again because division. So, but you won't end up with the same thing, you'll end up with complicated things. But, so, it's not me. Can be simplified a bit. To that, and then we shoot, they're acting in the opposite directions. Okay, so the y component is acting this way,
Oh,
this
yeah,
is
yeah,
YR,
yeah, yes,
and then we have mg acting down here, and we also have y of r. So this is equal to these two, or this take this is equal to mg. Yeah.
Yeah.
Can't write. I've got a duster. Why am I using my jumper?
I don't know, why you
Don't ask. R cos theta take mu r sin theta is all equal to m g. And I need to rub out this lovely arrow diagram. Sorry. R O mu no can't. Having.
Just have the duster in your other hand.
Yeah, I could just hold the duster all the time. Hmm?
How many more slides do we have of this?
There are a lot of slides. I think there's not many. Yeah, and then we can divide them again. And dividing will cancel these, and you get mu cos over. Yeah, you cancel it r's. Guess what? Or not guess what? It's kind of obvious. V squared over r over mg. And this thing is all over r cos theta take u sine. Cancel out that. Mu cos theta sine theta cos theta take mu sine theta is equal to v squared over rg. And then we can divide everything by cos. We get lots of tans. Cos, we love tans.
Because
No. We're trying to write this like I guess like that. And then we get mu tan theta over 1 cake tan theta. I remember there's a thing for 1 cake tan theta. I can't remember what it is off the top of my head. Oh, it's a mu, so it's not going to be. And then we can equate that to the earlier one. And really. And then we get b squared equaling a lot of brackets. R, G, U, Right, we have figured out that it can move faster. Because it just does. Oh, I'm going to square root it. It's not got enough space.
Just delete the squares on the B and then.
Yeah. Okay, we square root. There we go. That is the maximum velocity. And as we don't have numbers, we leave it in terms of RG, U, tans, all those lovely things that we like to leave things in.
no.
It's going to get all dusty with chalk, the keypads. You want to know how many there are. There are 26 slides.
That's all you're wrong.
We are on 17.
That was 2 a week.
Hmm?
I said we were on slide 15 earlier, then slide 17, that was 2 off.
Okay, we have the exact same thing. We solve horizontally. Oh, I need to rub this out. I didn't need to rub all of that out. Oh well, I have done now. Oh, we're given an angle. So radius 70, bank angle of 20, coefficient of friction being 0.3. So we have our. We're starting with horizontals because horizontals are nice. It's the exact same. We've got the x and y of the r, we have the FC, and we have the frictional acting in the said direction. So this is all equal to FC take. Mu is 0.3 in this. Cos? Yeah, cos. Probably have a new what we're here. Find the highest and lowest speeds. Well, that's fun. Again, we have values for this. mv squared over r, where m is unknown but r is known, so v squared over 7b. And then we can substitute that in, but yeah. And we get values being, why did I write it that way around? Why didn't I just add them in the first place? Don't know, oh well. R sine 20 and
There's
it's
a lot to add to our formula board.
Yep.
Oh, we might have to delete our Papa
Huh?
formula. We might have to get rid of our Papa Flummy formula for all the other formulas we're gonna add.
Well, these formulas are just, you know, the stuff from friction.
Still, might wanna have it there, or at least the demo revisions, maybe. I don't know.
Maybe, I guess. Rearrange, we can.
60 or 70% through the thing anyway, so
True.
we might be able to fit them all onto those two.
Yeah, we have a bit of space. Anyway, again, we have the mu acting in the opposite direction to the horizontal, the up of r. So we end up with r cos 20 is equal to mg added to mu at 0.3 sine 20. We can divide, wait, mu r sine, and we can move that over to equal it to mg, so that makes it easy. Cos 20 take 0.3 sine 20 is equal to mg. We divide through, we end up with sine 20 plus 0.3 cos 20 cos 20 take 0.3 sine 20 is equal to v squared over 70g, because we don't like having m's in our equation, because who does? And then we need to solve for r. Yeah, solve for v, which is quite simple. 70g sine 20 plus 0.3 cos 20 all over cos 20 take 0.3 sine 20, square root that, I'm too lazy, and then define, or we can just leave it as b, I guess. Oh, where did I put my calculator? Okay, we'll leave it as b squared, because we like b squared apparently. That's a whole number, not whole number, long thing. 511.314. Yeah. I really use dots on a chalkboard that easily. Or v is equal to. To the square root of the first doesn't matter. 22.6. So that would be the maximum speed, and then for minimum speed, friction acts in the opposite direction. Woo. So we have a diagram here. Lovely diagram. And then we just need to slightly rearrange what we've done before. Change some pluses into minuses, minuses into pluses, yada yada yada.
You go back slightly.
Oh,
Up.
didn't rub out the stuff yet. Okay, so friction acts up the slope. Horizontally we have FC So mu r, wait, but we still know what mu is. R cos theta is equal to FC add R sine theta. What? Yeah, R sine theta. You move the R over, put the 0.3, no I haven't put the 0.3 in the wrong place. I have put one of them in the wrong place. That is equal to that. Sine 20. Okay, they've got it the other way around to me, for some reason. That's why we had it last time. Well, R sine 20. Substitute in again with the mv squared over r is equal to r sine actually. And then we do the vertical again. R cos 20. And this is adding this time. R take out the R. Divide through. Oh, 70. And dividing through, we end up with, again, sine 20 takes 0.3 cos 20 all over cos 20 plus 0.3 sine 20 is v squared over 70g. Move the 70g up, we get v squared equaling a long number. Luckily, I don't have to do figuring out. 39.56. B is equal to somewhere about 6. So that is the two values, maximum on the left, minimum on the right. That's the point. The reason being, when there's something going fast, it'll want to slip up the slope. As it wants to slip up the slope, friction acts in the opposite direction, so it acts down the slope. When it's at a minimum speed, it'll want to fall down the slope, so friction acts up the slope. Hence why they have been done in this manner. I shall move out the way so that people can copy down this lovely stuff. paper did you use up? Oh dear. Weapon.